Hello everyone and welcome back to Nunley Math. I'm your host Aaron Nunley. Thank you so much for joining me here today as we examine the surface area of prisms and cylinders. Specifically, we're going to be looking at rectangular prisms, triangular prisms, and cylinders in this video. I'm actually going to split this video up into 3 separate lessons because that's how I plan to teach it in my classroom over the course of the next several days. I think there's a lot of information here, and I think the extra practice and giving my students time to really work with each type of shape is very important. So we're going to divide this up into 3 videos. I hope that if you enjoy this first one, you'll come back and watch the others as well. Certainly make sure you leave us a comment in the comment section if you see something that I might have messed up on or something that was helpful or unhelpful to you. Let's go ahead and get started. Before we talk about surface area, I want to ask you this question. How many squares does it take to cover this rectangle? Now, a rectangle, of course, is not a 3-dimensional figure. It's not a prism. It's a 2-dimensional or flat figure because it only has here height and length, or sometimes we would call this length and width. And I'm going to go ahead and tell you that this is going to be an inch square. It's 1 inch wide, 1 inch long, so we refer to this as 1 square inch. Can you use that shape to predict how many square inches you think it would take to cover this 2-dimensional rectangle? Now, it may be helpful to you if you didn't pause the video and try and guess that on your own. It might be helpful to you if I went ahead and covered the shape, at least the top row for you, with square inches. And if that's not sufficient, I could also show you how many inch squares tall or wide this figure is. Can you figure that out now? Hopefully that wasn't too difficult for you. It might be even easier if I just went ahead and covered the rest of the figure with squares. Obviously, you can count those up and you can realize that there are 24 1 inch by 1 inch squares, or 24 square inches that are needed to cover the shape. That's the definition of area. How many inch squares or centimeter squares, or how many squares of any size does it take to cover the entire 2-dimensional shape? Now, hopefully, if you're watching this as a junior high student, you can realize that if I had not physically drawn the squares for you, but had simply told you that it was 6 inches long and 4 inches wide, you could have used some elementary school mathematics, which says that if you have rows of objects arranged in an array, to find the total number of objects there are, you just take the length times the width. Or, in the case of this rectangle, it's 6 times 4, or 24 inches squared, or square inches. Does that make sense to everyone? Hopefully, because I don't want to spend a lot of time on 2-dimensional figures. We just want to remember what it means when we talk about area. Because in this lesson, we're going to take this 2-dimensional figure and we're going to stretch it backwards. And instead of using squares, we're now going to build it out of 3-dimensional cubes. Now you'll notice that this prism, this rectangular prism, is 6 inches long, 4 inches tall, but now it's also 1 inch wide. Now, I'm not going to spend a lot of time on the definition of prisms. If you need a review of that, you're going to want to go back and watch the video where we talk about the definitions of pyramids, prisms, and other 3-dimensional shapes. For now, I'm just going to remind you that this is a prism because the bottom or the base is a rectangle, the top is a rectangle, those are parallel and congruent, and all the other sides are rectangles as well. That's what makes this a rectangular prism. So, my question to you is, how many squares would it take to cover the rectangular prism? If you feel fairly confident with this, you can pause the video, calculate that on your own, and then come back and skim ahead and watch my solution. I'm going to assume that if you wanted to do that, you already have done that. And then I'm going to walk you through this real quick. Notice that I can use 1 inch square, or 1 square inch, the same thing I used over here on my 2-dimensional figure, and I can cover this spot here. And one here, and 1 here, and I can go through and do the exact same thing that I did over here on this rectangle. Since this rectangle was 6 inches long and 4 inches tall, I can cover this 6-inch long and 4-inch tall rectangle with the exact same number of squares. I've done the exact same thing. But because this is a three-dimensional figure, I also have to be aware that there are lots of other squares on the other faces or other sides of this prism that we have not yet covered. For example, if I were to look just at the top of this three-dimensional figure, you can see that I have a 6-inch long rectangle and a 1-inch wide rectangle. Now, certainly it doesn't look like a rectangle because we're viewing a three-dimensional figure and we're trying to kind of fabricate what that's going to represent, but we want this to represent 1 inch. So it's 6 inches long and 1 inch wide. How many squares would it take to cover that? Well, that's 1, 2, 3, 4, 5, and 6. In fact, I could also find the area of this rectangle by taking it length times width. Length times width, which is 6 times 1, which is, of course, 6. Notice here that we still have more sides that are not yet covered. If I want to find how many squares it takes to cover the right side, I'm going to notice that this is 1, 2, 3, 4 inches tall and 1 inch wide. Again, these don't look like rectangles because we're viewing it at an angle, but when I go to a three-dimensional model here in just a second, hopefully that will make a little more sense if it's confusing to you now. Notice 1, 2, 3, 4 squares are needed to cover that side. Well, that's because the width is 4 and the width is 1 and the height is 4 for a total of 4 squares. So it took us 24 squares to cover the front, 6 squares to cover the top, and 4 squares to cover the right side. So is this figure completely covered? Well, not exactly. If you're not sure about why that would be, pause the video and think about it for just a second. I'm going to go ahead and explain why that is for those that already know or couldn't figure that out. And to do that, I'm actually going to hop out of this program for just a little bit, and I'm going to hop into this program that I sometimes use in my class. This is called Shapes. I have a website where you can locate this app if you decide you want to use this on your own or if you're a teacher to use it in your classroom. I'm going to pull up a prism and I'm actually going to look at, let's see, do I have a nice, let's see, let me pick this one over here. No, that's the cube. Let me go back to a different one. Here we go. Here's a quadrilateral prism. A quadrilateral is a four-sided figure, so this is very, very similar to our rectangular prism that we're already working with. I want you to notice something. I want to kind of set it up so we're viewing it the same way that we viewed our prism in the picture. Remember how we had the front, we had the top, we could just kind of see the side. Notice if I turn it, even though that doesn't look like a rectangle when it's in this position, it still is a rectangle on that side. Same thing with the top. The top doesn't look like a rectangle, but if we turn our view, you can see that it is. And here's what I'm going to do. I'm going to go ahead and paint the sides we already looked at. We looked at the front, we looked at the top, and we looked at the right. But have we covered all the sides? Well, no. Notice that we do have the top covered, but the bottom has yet to be painted. If I come over here, I've painted the right side, but I have not painted the left side. And I've painted here the front, but I've not painted the back. You see, when we're viewing a three-dimensional figure from a certain position, we can't always see all the sides that are there because one side will block the other. I know back here, way, way back on this side, is the side that's opposite of this. Because this is a prism, this and this are going to be the same size. This is the front, but I know, even though I can't see it way over here in the back, there's going to be a matching side. And I can see the top, but because this is not a see-through object, I can't see the bottom. Now, here's something that's kind of cool. I can actually change this. There it is. I can actually change this so we can see through the object. Notice that these dark lines are outlining what is visible to us in our picture on our other slideshow, but these narrower, thinner, lighter lines are representing the lines that we know exist, but we can't actually see. Again, here's the figure solid. Notice I can't see this backside. But if I make it transparent and I can see through, we know those sides actually exist. And then here's just a figure that does not have any coloring to it at all, and all the sides are made to look the same. Let's go back to our slideshow for just a second. We're going to hop back over here. So what that tells me is that there are three other sides that are visible or that are in. What that tells me is there are three other sides that I still need to cover that I can't actually see in this figure. I know there's a front right here, but there's also going to be a back. I know that there's a right side right here, but I also know there's going to be a left side that's the same size. And I can see the top, but I know there's also a bottom that matches. So, since the back and the front are the same size, if the front is 24, then the back must also require 24 squares to cover it. Since the top required 6 squares, the bottom will also require 6 squares. And since the left side required, or right side required 4 squares, then the left side will require 4 squares as well. Yes, I'm aware I have a typo here. I'll go back and fix that later on. This should read the bottom, because the bottom and the top are opposite from one another. Thought I got all those. There you go. Now, what does that tell us? Well, that means that if I want to find the surface area of this shape, I'm going to look for the total area of all the exposed surfaces, whether I can view them or whether I can't. In the case of this rectangular prism, there are 6 total surfaces that would be exposed. 6 surfaces that would be exposed. There are 3 that I can see, and there are 3 that I cannot see. So all I'm going to do is take them and add them up. Since the front and back are the same, if you want to do this with multiplication, write it as 2 24s, you can do that. Same thing with the top and the bottom. Same thing with the left and the right. Notice if you want to practice the distributive property, you could just add all 3 exposed faces together, which would be adding these all together, and then just double it to get the other side. I would not expect my students to write all 3 of those. I would expect them to write it one of those 3 ways. And that would give you a total surface area of 68 square inches, which is hard to see because I drew on top of it. There you go. Total surface area is 68 square inches, meaning it would take me 68 1-inch by 1-inch squares in order to cover the entire surface of this 3D object. And that's basically it. That's surface area of rectangular prisms. Now, what I'm going to do is I'm going to walk through several examples of this and give you a chance to practice this on your own. Don't forget, if you want to go back and look at the 3D shapes from multiple views, you can go to shapes.learnteachexplore.com and it'll show you how to download the Shapes app we were just using. Now, here's another rectangular prism. I would suggest that if you feel comfortable, you try this on your own, and then you can skip through my explanation and just see if your solution matches mine. If you're struggling just a little bit, you might want to work along with me as I go. I'm going to do this first one in extremely painful, tedious detail just to make sure that every question that could possibly come up gets answered, and then in successive examples, I'll do less and less. So, I have a three-dimensional figure. I can tell it's a rectangular prism because the top and the bottom are both rectangles and they are connected by rectangles all the way around. Remember, the top and bottom here would be referred to as bases. Two rectangular bases connected by rectangles. So that tells me that when I go to find my surface area, or the area of all the exposed surfaces, I'm going to need to find the area of 6 different faces. There's going to be the top and the bottom, the right and the left, the front and the back. And since they're all rectangles, I'm going to use my rectangle formula every single time. So, excuse me, let's start with the top here. Notice that the top rectangle does not have any measurements on it. Now you should, from the information you're given here, be able to figure out what the dimensions of that rectangle are. Sometimes students struggle with seeing how, which sides are what lengths. So here's a tip I give my students. I often tell them if you're having trouble telling how long sides are that aren't labeled, you can always go through, can you see that I'm highlighting this? And you can highlight your sides that are all parallel to one another. Notice this is a horizontal line, this is a horizontal line, this is a horizontal line. When we're doing two-dimensional representations of 3D figures, all the lines that are parallel like this are going to be the same length, which means this is 10, this is 10, and this is also 10. Using a highlighter is a great way to make sure that you don't miss that or forget that or get them confused. So I know the length of this rectangle is 10. I also need to know the width. Notice that it's not labeled either. Can you tell how long that should be? Well, hopefully you realize that if this is 8, this is also 8, and this is also 8. Notice all these lines are parallel to one another. They're all slanted the exact same amount. That's how I know those are all 8, which means this figure is 10 long and 8 wide, which gives it an area of 80. If I want to know the bottom, since this is a prism, I know the top and the bottom side that I can't see are also the same area. They have the same dimensions, they're the same size. So I can just write that down. Notice I didn't take the time to recopy the formula, I didn't recopy my calculation, I just plugged in the number. Let's do the right side and the left side. Now here I've got the left side for you. Here I've got the right side for you. They're both the same size, so even though these are labeled backwards, it's not going to make a difference which one is which. So, if I want to know the area of this rectangle, notice the 8 is labeled, the 5 is also labeled. This rectangle is a 5 by 8, so it's going to require 40-inch squares or square inches to cover it. And the left side and the right side are both going to be the same, so I'm just going to write the other one down. Notice I did not take the time to rewrite the formula or the computation here, I just brought the number down. That leaves me with the front and the back. Notice the front is this green side that's left over here. We can tell that it is 10 centimeters long, but we don't have a measure for how tall it is. Can you figure that out? Here again, I'm going to highlight for you. That's the rectangle I'm talking about. The 5 that I have back here is going to match all the other vertical lines. Notice these are all parallel to each other. They're all the same length. That makes this rectangle a 10 centimeter by 5 centimeter rectangle, which is 50 square centimeters. The back side that I can't see is going to be the same. In order to find the surface area, I need to find the total of all the exposed surfaces, so I'm just going to add all these together. And I'm going to come up with 340 centimeters squared. 340 centimeters squared. Now, When I do this, I like to set it up as a table. I actually often will have my students write the faces down and then show their computation and then give the areas, because then it's easy to add up. If you're somebody who struggles with math, this is a great strategy. If you don't want to do all that writing, I will sometimes just label these as T, B, R, L, F, and maybe a lowercase b, and then total. That will cut down on your writing quite a bit. Also, if you want, you don't necessarily have to draw yourself a fancy table and use your ruler, make lines. You could just use lined paper and do the same thing. The important thing is the setup and the organization. The more organized your strategy is, the better off you're going to be. Now, if you're a student who feels fairly comfortable with this, you could also just go ahead and do this as a formula. The surface area is going to be the front measurement, that's the 80, or sorry, that's the 40, twice, once for the front, once for the back. You could do the side measurement, which is the 40, if you're If you're somebody who feels fairly comfortable with this already, there's a few things you can do to do this a little more quickly. I let my students use this formula that says the surface area is equal to 2 times the front, because that's the front and the back, plus 2 times the side, that's the right and the left, plus 2 times the top. That's these added together. Remember, we're doubling because we know that for each side we can see, there's a matching side that we cannot see. If you use that, you could just go through and plug in the numbers that we used before. The front was the 5 times 10. The side was the 5 times 8. The top was the 10 times 8. And you could just work this out using order of operations. This is 2 times 50, 2 times 40, and 2 times 80. And you get 340 centimeters squared. Now, I would like for my students to definitely show this step. This step is an optional step. These steps you might want to show if you're being particularly careful, but I would not necessarily require all of them. If you have a multifunction calculator or a newer calculator, a lot of times they will do those order of operations for you. But you definitely want to make sure you include the final answer, including the units. Remember, we're covering the shape with squares, with things that measure 1 centimeter in 2 different directions, so make sure you put your units on the end. Tell you what, try this one. I'm going to highly recommend you pause the video and do one or the other of these methods. I would not expect you to do both of them, and certainly you can you can then watch the video when you're finished and see whether you're doing these correct or not. I'm going to assume if you wanted to do that, you already have, and I'm going to work through this one a little more quickly. Notice I start with the same pattern, top, bottom, left, right, front, and back. Notice that my top is the orange rectangle. I can tell the length and the width of this orange rectangle because I know this is going to match the 18, this is going to match the 12. And there's my area. The bottom's going to be the same. When I go to do the right side is pretty easy to see, as is the left. I've got those switched. Right and left is going to be the 3 by 12. The front side is this green rectangle that's left. It's 18 by, there's no number here, but I know this is going to match the 3, giving you a total of 612 centimeters squared. If you prefer to do it this way, just plug in your measurements for the area of the front, plug in your measurements for the area of the side, and plug in your measurements for the area of the top. And you get 612 inches squared. Again, I got a typo, got to go back and fix that. These are inch squares. Always make sure you're watching those units carefully. One more. Again, I'm going to do this one much more quickly. I would suggest you pause the video, try it on your own, and then watch my solution. If you feel pretty confident, you can skip through my explanation and jump straight to the solution. And then if you get it wrong, you can go back and listen to the explanation. I do want to point out that this is 7 meters long, but notice that there are no other measurements along the side. but they do have congruence marks. That tells me that all of these sides are going to be 7. That also tells me that this side over here is also going to be a 7. You may find that to be helpful. Here's my table again. Notice the top is 15 across by 7. The bottom's going to match. The right is this 7 by 7 square, which I drew very poorly. The left is going to be the same. The front is going to be the 15 by 7, which is 105. The back is going to be the same. And it looks like I missed an animation here. We'll add that back in. Or when you add them up, you get 518. If you want to do it in formula form, you can just stick your front measurements in here and double it to get the back. Side measurement, double it to get the other side. Top measurement, double it to get the bottom. And you end up with the exact same set of solutions. Hopefully that's extremely helpful for you. I'm going to go back and fix those typos along the way, but hopefully that made sense for you. If not, I would suggest that you watch it a second time. I will tell you that the hardest thing for most people when doing surface area problems is keeping track of which shapes they're working with. It's fairly straightforward when we're dealing with rectangular prisms because they're all rectangles, but you're going to find the other shapes that we work with, you're going to have to use different formulas when you're finding the area of each side. We'll talk about that more in the next video. As always, thank you for watching. Make sure you turn on your notifications so you'll know when this next video comes up. Make sure that you like and subscribe. Leave us a comment in the comment section so that we know if this is working for you. Thanks again. Best wishes to you all. You all take care of yourselves, all right? Bye-bye.